Hi everyone, in this video we look at reflections about the y-axis. So the graph of y is equal to f of minus x is a reflection of the graph of f of x in the y-axis. So let's say I have a point that's, at, let's say I have a point at 2 comma 1 on the graph of f of x, while on the graph of f of minus x it would be at minus 2 comma 1. So it's a reflection about the y-axis. So we can use this reflection or this transformation if we have a graph such as f of x is equal to x cubed, then we can look at what transformations have been applied to this function, and we can use these transformations to sketch the transformed graph. So let's go ahead and we'll do that. Well, let's look at x cubed, and then let's try to graph f of 2 minus x plus 1. So first, let's sketch the parent function f of x cubed. F of x is equal to x cubed. This graph has points 0, 0, 1, 1, and 2, 8, which is right here. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. And it has point negative 1, minus 1, and minus 2, negative 8, which is right here. So let's sketch a smooth curve through these points. Whoops, I can do a little bit better than that, I think. So let's just do that. Whoops. Let's do this half first. There we go. That's pretty good. And then I can do this half of the function. Okay, so it should look something like that. So this is the graph of f of x. Now let's look at the graph of f of 2 minus x plus 1. And let's first figure out what transformations have been applied to this function. So let's rewrite this as y is equal to f of minus, bracket, x minus 2 plus 1. So now we can see that there is a horizontal reflection. So a horizontal reflection, or let's say a reflection about the y-axis. So this is a reflection about the y-axis. And we have a, from this minus 2, we have a horizontal shift 2 units to the right. 2 units to the right. And we have a vertical shift 1 unit upward. Vertical shift 1 unit upward. Notice something here, that I rewrote this so that I common factored out the negative. So I wrote this in the form, I wrote it in a form such that I have a coefficient of 1 beside x. If there's a coefficient beside x inside of your function, you have to common factor that out of these two terms to figure out what the transformations are. So, let's say you have f of 2x plus 3. Well, to figure out what the transformations are, you'd have to write this as f of 2 times x plus 3 halves. And this would be a, we'll talk about more about what this transformation is, but this would be a horizontal compression by a factor of 2, and a horizontal translation 3 over 2 units to the left. But when it's written in this form, you can't tell right away what the translation is, because you have to common factor this the coefficient on x out of both of these terms. And we'll look at why that's true in future lessons. So now we can go ahead and we can transform our function. let's reflect this about the, let's reflect each of these points about the y-axis, and then shift them 2 units to the right and 1 unit upward. So if I take this point here and I reflect it about, if I take 0, 0 and I reflect it about the y-axis, I just get the point 0, 0, because the point lies right on the y-axis. Then I'm going to move it 2 units to the right and 1 unit upward. So this point transforms to this point right here. It maps to this point. We call this point here the image point of the point 0, 0. So this is called the image point. Let's look at where this point maps to. Well, first off, we have to reflect it about the y-axis. So if I reflect it about the y-axis, I have this point here. And then I'm going to shift it 2 units to the right, 1 unit upward. So I have a point here. Lastly, I'll reflect this point about the y-axis, shift it 2 units to the right, 1 unit upward. So I have a point here on my graph. Next, let's do this point. So this point I'm going to reflect about the y-axis, which is here, shift it 2 units to the right and 1 unit upward. And then I'll take this point here, reflect it about the y-axis, shift it 2 units to the right, 1 unit upward, so I have a point here. So you can see that the graph of f of 2 minus x plus 1 is a reflection about the y-axis, then we shift it 2 units to the right, 1 unit upward. And again, we perform reflections before we perform any horizontal shifts or vertical shifts. So let's go ahead and we'll finish this off by drawing a smooth curve through these points. So my graph should look something like this. So this is the graph of f of 2 minus x plus 1. In the next video, we'll look at how to graph functions involving stretches and compressions.